Year 11, welcome to our first video. It's exciting. I don't know if you've done these before. Now look, what I'm going to ask you to do, we'll talk through it in class, but I want you to watch these videos at home. You can pause, you can rewind, you can watch it again. That's what I do because they're great. But anyhow, you can watch them in YouTube and play them faster. So I talk even faster than this, or you can play them slower, and I don't know why. But nonetheless, right, I need you to watch these at home and watch it again if you need to until you know what we're doing. We're going to start today with some algebra skills that I would hope you're probably already pretty familiar with. Let's have a look. First of all, collecting like terms identical except possibly for their coefficients. They're good words. You'll see these words on the front page of our notes. If you're not sure what they mean, well, check them out. Look them up. Anyhow, first example here, simplify, right? Simplify, this is not solved, we don't find the value of that pronumeral, we're just going to simplify this expression, which means there will be fewer terms at the end. Now, which of these are like terms? The 7a and the negative 2a. Remember, the sign in front belongs to that term, so the 7a and the 2a, negative 2a are like terms. Check an equal sign in here, because it's going to be equivalent to, right, 7a minus 2a is equal to 5a. And the 15 and the negative 20, they're like terms. 5a minus 5 is a simplification of that expression. Over here, now I have lots of terms here with x's in them, but some of them are squared and some of them aren't, and those that are squared are not like terms with those that don't have an exponent there. Okay, so let's just work through these. I'm a bit rusty. Not with the maths, with using this screen. So, x squared and another 3x squared. Okay, these are like terms. It's always good to work from the biggest power to begin with, generally. So, I've got an x squared and another 3 of them. That means I've got 4x squared terms. All right, 4x squared. I've got a 2x and minus 4x is minus 2x. And finally, there's a negative 3 there. There are no terms like that constant negative 3, so that means 4x squared minus 2x minus 3, like that. Moving along, multiplying and dividing terms. While we can't always add and subtract terms as such, we can't simplify always. If they're not like terms, we can multiply or divide whatever terms we like. We'll always get something. So let's have a look and see how these work. 3y by negative 6y. Okay, we've got brackets around the negative there. Sometimes you'll see those, sometimes you won't. Work essentially from left to right. Work with coefficients first. 3 by negative 6 is negative 18. Y by y is y to the power of 2y squared. Okay, like that, done. Next up, 4ab by 7bc. So 4 7s, 28. That's just the a. We've got 2 b's being multiplied together there, so that gives me b to the power of 2, b squared, and a c. 28, a squared bc. And now we divide by here. Sometimes we need to write these as fractions, we're going to end up with fraction, but these are pretty neat and tidy. You can see those coefficients are going to cancel out. 10 divided by 5 equals a neat and tidy 2. X squared divided by nothing is x squared, right? That doesn't change. And the y divided by y equals 1. Now I don't need to put that in there, so that's my answer, 2x squared. Right, multiplying and dividing terms. You'll have done these before and you're going to get plenty more practice today. Right, moving along, index laws. I don't really need you to remember the wording of these or the order of them or something like that, but I really do, for this course, I really do need you to remember how to apply all of those rules. They might seem a little straightforward here to begin with. You're going to find complicated ways of using these, so you've got to be really strong with them. Right, a few more examples to work through, and this first video will be done. Right, so start with the coefficients. 3 by 4 is 12. Now, x to the 4 times x to the 3, this is going to be, what we can see is our first rule here. We have the same base, so I can add those coefficients. Not coefficients, I add the exponents, that little thing, sometimes called an index, but an exponent is a good word. So x to the 7, 12x to the 7, very nice. Over here, now we're dividing, but again, this is going to be pretty neat and tidy, I think. So 48 over 16, well, I think there are 3 16s in 48. I get a 3 there. Now the x to the 7 divided by x to the 5, x squared, y cubed over y cubed. Well, that doesn't become 0, it becomes 1, right? I don't need to put the 1 there. 3x squared is my answer. Neat and tidy. All right, that's a good example of the second of those index laws is listed here. Now we have what we call a power of a power, perhaps. So this coefficient. The 3 is inside the bracket, so I do 3 to the power of 3. I'll give you a clue, it's not 9, it is 27. 3 times 3 times 3 again. So I get a coefficient of 27. a to the 4 raised to the power of 3. In this case, I multiply those two things together, because it's really a to the power of 4 times a to the power of 4 times a to the power of 4. I would add those up. Gives me a to the 12. 27 a to the power of 12. Yeah, coefficients again, negative 10. Now, I want to take care of these first. Oh, geez, that's very untidy. See what's happened there? I've rushed ahead without reading that question carefully. I think really we want to take care of these exponents before we do the multiplication. Remember, your orders of operation, indices, come before multiplication. So, let's take care of this first term first. I'm going to get negative 125 x to the power of 6. I'm going to multiply that by 2 to the 4. What is 2 to the 4? I think it is 16. 16 x to the power of 4 y to the power of 4. Right, now, I really should check this out before. 16 lots of negative 125. Well, 4 lots of negative 125 would be negative 1,000, so it's going to be negative 4,000. Negative 4,000 x to the 10 y to the 4. I apologise that this writing is not terribly neat. Hopefully it'll get neater throughout the year to get a bit more practice using this stylus on the slippery screen. Anyway, negative 4,000 x to the power of 10, y to the power of 4. And finally here, we have, remember, that's 16 x to the power of 4 over 3 to the 4. That would be 3 27s is 81. 81 y to the 4. That's all powers of 2, that's all powers of 3. They're definitely not going to cancel. Okay, like that, that's not so bad. Questions, queries, doubtful points? Please, as you watch these videos, if you've got any questions, jot them down, ask them in class. That's how this works. We'll talk about that more in class. We probably have already. Anyhow, thanks very much. Hope you enjoyed it.